Site preparation is a huge program in British Columbia. In the past decade, more than 1.2 million hectares have been site prepared. Research clearly shows how much it helps seedling establishment and early growth. One of the most rapidly expanding methods of site preparation is the excavator. From only a handful of excavators a few years ago, there are now more than 100 excavators doing various site preparation treatments throughout the province. Excavators were first used for site preparation on steep, slashy sites on the coast and on wet sites in the northern interior. Dr. Bob McMinn's early trials using excavators for mounding showed the potential benefits of this treatment. Companies like Northwood Pulp and Timber tried excavator mounding as an alternative to prescribed fire. Dave Presley is the manager of silviculture with Northwood.
Northwood was one of the first companies in the north central interior here to use excavators for site preparation. We initially got into site preparation with excavators because of the poor plantation success we were having on some of our ecosystems that were typically broadcast burn. Other impetus for changed movement towards excavators has been the new site degradation policy and the smoke management guidelines. To this day, excavator scarification is the vast majority of our site preparation in this operating area. This site was logged 5 years ago, and normally we would have broadcast burned this site. However, it was decided that we'd try excavator mounting as an operational trial. It was subsequently planted 4 years ago, and this is the result today, a successfully established plantation.
Because they can be equipped with various attachments, excavators provide a wide range of site preparation treatments over a small area. In this video, we'll discuss why excavators have become so popular, what's out there in the way of attachments and treatments, skid trail rehabilitation, operational considerations, and future directions. The increase in the popularity of excavators results from the decline in the use of prescribed fire. Public pressure to reduce smoke emissions and increasing cost and liabilities have forced forest managers to come up with other strategies to treat these sites. John Wallace of Adams Lake Lumber.
The main reason why Adams Lake Lumber has been using excavators is because we found them to be extremely versatile. They're versatile in the way they can work on steep slopes. What we found is with other pieces of mechanical equipment, they've been very effective in some cases on working slopes up to 30%, but with the use of the excavator we've found that we can effectively treat a slope of an average of 50% safely.
On wet sites, an excavator equipped with wide pads can work where other equipment would bog down. Excavators can also reach into wet areas without actually having to traverse them. On sites with a high soil sensitivity, excavators have less negative impact than machines like crawler tractors because excavators don't have to traverse the whole site. Rather, they can treat an area twice the maximum boom reach in one pass. Good visibility and control over the rake attachment gives excavators a distinct advantage in preserving rich soil horizons or advanced regeneration. While offering a wide range of treatment options, an excavator can also do other work, such as road repair for planter access, rehabilitating skid trails, and putting in and repairing culverts.
The excavator is an excellent piece of equipment to have on site after the time of logging. Not only does it effectively prepare our cut blocks for planting, it also allows us to have a piece of equipment there to water bar our skid trails to ensure that we don't have erosion problems. Also to do any ditching that may not have been completed, in particular when the block was logged in the winter.
Finally, excavators are readily available. They are a proven machine and are rugged and reliable. This, combined with their versatility, trafficability, and sensitivity, have made them extremely popular. With their good mobility on wet ground, excavators are well suited to mounding. By using an excavator to mound, rather than other row-type mounders, the operator can tailor each mound to the existing microsite and soil conditions, successfully deal with heavy slash, and mound on sloped ground with a high water table. However, these benefits are only realized if the operator knows what's required and understands the basic biological reasons for mounding. This is also true for the planting contractor.
When planting mounds, it's extremely important where you place the tree. Here's a tree planted up on top of the mound, and we see it doing extremely well. Whereas this tree down in the bottom, planted in the hole, we see doing extremely poorly.
For inverted mounding, two main types of excavator attachments are used: buckets and specially designed mounding rakes. Buckets have the advantage that the contractor typically owns one and is comfortable using it. However, mounding rakes were developed to overcome buckets' inadequacies and are preferred in most situations. On wet sites where large, mucky organic mounds are required, buckets do perform better than mounding rakes, and some specially designed buckets have been produced. Mounding rakes usually consist of 2 or 3 main tines, a curved plate for scooping mound capping material, and 1 or 2 rows of small kickback tines. A mounding rake forms a mound in a 2-step process. First, the spot is cleared of slash and excessive loose organic debris. This is done using the kickback tines while pushing the boom out in a backhand motion. The second step is to dig the rake into the cleared spot and pull it towards the machine, thereby scooping and rolling mound capping material into an inverted mound. Experienced operators have found this to be the most efficient way to consistently produce good mounds. Developing and maintaining a consistent treatment pattern can help increase productivity and maintain spacing. Experienced operators tend to work in a semicircle pattern within rough windrows of slash or brush. The operator produces mounds behind and on either side of the machine, before advancing to the next machine setup. By repeating this pattern, a strip approximately 2 boom lengths wide is treated in one pass. Note also that by working behind and to the sides, the machine never travels over treated ground. While mound size and shape will vary with prescription and site conditions, good mounds generally have the following characteristics. They are flat or concave topped, with gently sloping sides. Mound capping is sufficient to raise the seedling roots above the water table, warm the soil, retain moisture, and hold back competing vegetation. The mound has good contact with the ground below and is not perched on slash, debris, or thick, loose organic material. Care is taken not to remove too much of the organic layer, as mounds placed on exposed mineral soil are often poor growing sites. The mound has not been separated from the hole. This is especially important during periods of summer drought to facilitate the upward flow of water by capillary action. To review, the mounding rake forms proper mounds in a 2-step process. The spot is cleared of slash and excessive organic material, and the mound is formed with a scooping or rolling action toward the machine. Powered attachments to produce mounds of mixed organic and mineral soil have also been designed and will be discussed later under mixing attachments. Increasingly, excavators are being used for windrowing slash and screefing. Previously, these treatments had been done by skidders or crawler tractors, or the slash had been burned. However, as the cost of prescribed fire has increased and greater emphasis has been placed on preserving soil productivity and standing residual timber, excavators have become a popular choice for this treatment. Excavators used for windrowing slash are usually equipped with wide rakes and live thumbs. Like the mounding rakes, these slash rakes have 1 or 2 rows of smaller kickback tines, which are used to push slash away from the machine in a backhand motion. Windrows are formed on either side of the excavator, parallel to the direction of travel. The excavator rolls slash out from the front and sides in a semicircle of 1 boom length radius. This way, the machine is traveling over slash-free ground that has already been treated. It's more productive to roll slash out from the machine into windrows than to pick up, swing, and pile material using the thumb. Also, the repeated rolling of the slash makes a cleaner pile. In fact, contractors are now mounting slash rakes with the curve facing outward with good results. When slash is light and screefing is the only treatment required, a smaller screefing rake is sometimes used. When screefing, remove only the slash and loose surface organic layers. Leave the rich surface soil horizons in place. Contractors also use modified buckets with extended or extra teeth. However, the tendency when screefing with a bucket is to remove too much soil. Follow a treatment pattern similar to that used in mounding, with patches or screef strips 4 to 6 meters long. When working on slopes, most operators prefer to work with the boom downslope for stability. On very steep slopes, the excavator must deadhead uphill after each treatment pass downhill. While deadheading, the boom is extended forward for counterbalance and is sometimes used to grab solid objects, such as large stumps. Mixing is prescribed on sites where it's desirable to mix the forest floor and underlying mineral soil. Row mixing implements, like the Madge Rotoclear or Eden bedding plow, are limited to sites with gentle terrain and little slash or stones. So the recent development of excavator mixing attachments makes spot mixing a welcome and viable option, particularly on sites with a high risk for site degradation. Spot mixing minimizes the area of soil disturbed. Development of excavator mixing attachments has branched into two concepts: the rotating disc or the rotating shaft or drum. Rotating disc mixing attachments include the Slash Buster and the VH Mulcher. The VH Mulcher was developed in 1991 specifically for site preparation. The production model features a variety of mixing heads, each suited to a particular application, such as screefing or mounding. The egg beater head seen here rotates at 40 RPM in either direction and is designed for deep mixing and mounding. To mound, the slash is first pushed off. Then the head is inserted into the soil, pulled up, and tilted to form a mound. Changing heads is relatively simple and can be done in about 15 minutes. Rotating shaft or drum mixers include attachments such as the Mitsui Miike, the high-test tiller, and the Murray tiller. The high-test tiller was developed in 1992 specifically for site preparation. It's essentially a large rototiller with rakes on either side for clearing slash. It's also equipped with a live thumb for piling slash or other debris. The tilling drum has hooked teeth and rotates at about 90 RPM in either direction. Like mounding, mixed planting spots are created in a two-step process. First, slash and excessive organic debris are cleared off using either rake. Then the remaining organic layers are mixed with the mineral soil beneath. To create a mounded spot, the tiller is simply held in one location longer and pushed in deeper. The Murray tiller is another attachment developed in 1992 for site preparation. Unlike other spot mixers, the Murray tiller rotates at high speed to break up propagating plant parts and produce a fine mix. The toothed shaft rotates in either direction at approximately 200 RPM and is enclosed in a protective shroud. While promising, this prototype attachment still requires considerable development. Another growing use of excavators is in the area of forest health. A specialty attachment called the clam bucket has proven particularly useful in a number of applications, ranging from push falling and stump removal in areas infected with root rot to harvesting in tricky blowdown situations. The clam bucket is also used in site preparation, removing and piling clumps of alder. Skid trail rehabilitation is another new treatment which is best suited to excavators. Skid trail rehab attempts to re-establish natural soil horizons on a cut skid trail. Crestbrook Forest Industries, located in the Kootenay region of BC, is one of the pioneers in the rehabilitation and recontouring of skid trails. Forest soils are comprised of various layers, or horizons. A typical soil contains an A horizon, which is the dark, nutrient-rich topsoil, a B horizon, which is found below the A horizon and is somewhat enriched with minerals and organic material, and finally, the C horizon, which is the nutrient-poor, often compacted parent material. Lying on top of the soil horizons is a layer of built-up, partly decomposed organic matter called duff. When skid trails are built, mineral soil is exposed, often down to the C horizon. This presents a very poor microsite for germination and seedling growth. Skid trails also disrupt the flow of subsurface water down the slope and may increase the risk for erosion and mass wasting. These considerations, plus the fact that they are unattractive, are important given the high recreation use and number of fish-bearing streams in the area. Faced with these problems, Crestbrook decided to experiment with trail recontouring, rather than to totally change its harvesting techniques to cable systems. Crestbrook found excavators were better suited to constructing those trails destined for rehabilitation than crawler tractors because they had better control over where the excavated material was placed off the trail, making it easier to put it back in the reverse order. They could construct trails up a steeper gradient, and overall, excavators tended to produce narrower trails. After the soil horizons have been placed back in reverse order, slash and other woody debris is pulled back on top. This is done to dissipate the impact of raindrops falling on the trail, thereby reducing the risk of surface erosion. As well, this provides for long-term nutrition through decomposition and offers shaded microsites for germination and seedling growth. Duke Armletter, Crestbrook Forest Industries.
A reclaimed trail presents many benefits in that it has many favorable microsites. It's an irregular surface. There's organic matter put on top, so you'll get shading and better moisture retention. And this is very, very important on such a hot, dry, south-facing slope as such. Much better than the situation we see off the trail with a bit of a duff layer, which will cause desiccation of any seeds that do fall on it.
In fact, not only has Crestbrook noticed improved natural regeneration on reclaimed trails, but also good seedling growth. Another benefit of reclamation is the reestablishment of subgrade drainage. When subgrade drainage hits a cut skid trail, it will usually surface, run down the trail for a little while, and then be fed off with a cross-ditch. Not only does this increase the risk for erosion, but also concentrates the available water downslope. With successful rehabilitation, the soil profile is restored such that subgrade drainage can continue down the slope, providing an even distribution of the moisture available over the whole site. To ensure that this natural drainage is restored, the running surface must be prepared by either continuous ripping or frequent trenching prior to replacing the soil horizons. When reclaiming the trail, it's important not to disturb the slope above the cut, nor to gouge deeper than the sidecast material on the slope below the cut. Crestbrook feels that its success in site rehabilitation can be measured by how hard it is to tell where the trails used to be. Before prescribing an area for excavator site preparation, the forest manager must consider the following operational factors: excavator specifications, operator training, safe operating techniques, and site degradation concerns. All excavators are not alike. The combination of models and options tend to make one more suited to a specific application than another. Boom reach, size, and power are the most obvious considerations, but having the proper track pads and grousers can also make a big difference. Mid-sized excavators in the 85 to 95 kilowatt size class, such as the new 200 series models, are suitable for most jobs. When windrowing and piling heavy accumulations of slash, or when other roadwork is required, a larger model with more power and a greater boom reach may be more appropriate. On wet sites with a low bearing capacity, smaller excavators equipped with wide pads are preferable, whereas on slopes, narrower pads with deep grousers or ice lugs give better traction and safety. No other form of site preparation gives the operator such precise control over microsite formation. Therefore, it's vital that the operator understand the treatment objectives and has clear instructions as to what is required. This is especially important when several treatments are to be carried out on the same site. A pre-work conference is a good start, but must be followed by random check plots and ongoing supervision, especially when conditions change. Safe operating techniques are also important, especially on steep slopes. Although excavators have been used safely on slopes up to 50%, an operator should not be pressured into any situation where he does not feel comfortable. In most cases, it's preferred to work up and down the slope. However, when working across slopes, several techniques can be employed to reduce the effective slope. Follow the natural contours of the site, reaching up and down to treat any particularly steep pitches. Cut a small trail for the upper track to rest in. build up a debris pile for the lower track to rest on, or rest the lower track against a solid stump. In any case, it's wise to clear away any large slash and ensure the tracks are on solid footing before swinging around to treat an area. On some areas, the potential for causing site degradation will be higher than on others. It's important that the operator know the leading hazards, know what types of disturbance are considered detrimental on that specific site, and know how to recognize them. As we improve our ability to fine-tune site preparation to site conditions, we'll see more prescriptions requiring 2 or more treatments within a single cutover. This is already the case where excavators are being used to screef and windrow on some portions of blocks and mound in the wet draws. Excavators are also being combined with skidder or crawler-mounted units to treat single blocks with varied conditions. As we log more difficult blocks, we'll continue to need equipment which can safely treat slopes greater than 50%. 2 promising concepts are the Valmet 500T and the Kaiser Spider. The Valmet combines a self-leveling Timco undercarriage with a lightweight telescopic boom. At full extension, the boom is capable of reaching 32 feet, 10 meters, either side of the machine. While this machine works fairly well, some redesign of the boom is needed to increase its ability to assist the machine up slopes. The Kaiser Spider is a climbing backhoe manufactured in Europe. This machine can literally walk. Equipped with an auxiliary winch and power to the rear wheels, this new Spider has no real upper slope limit. Like its predecessors, productivity is slow. However, the X4 Turbo is vastly superior to previous models. It may be a good machine to combine with standard excavators for treating especially steep pitches. Site preparation in the future will continue to place more emphasis on preserving other values, such as soil conservation, residuals for aesthetic value, or wildlife. Excavators' ability to treat sites effectively while maintaining residual cover will continue to contribute to their widespread application. Excavators already play an important role in British Columbia's site preparation program. While the development of new attachments and techniques has increased the versatility of excavator treatment, only through the vision and hard work of equipment operators, contractors, field foresters, and technicians will we achieve a successful regeneration program.